So we talked about homologous structures, which are when we see similar structures among related groups of organisms because they came from a common ancestor. But there's also things called analogous structures, which come from convergent evolution, which means that there's structures that are similar between groups of living things that are not related at all. These structures did not come from a common ancestor. They just so happen to have evolved twice. So converge means to come together, and so this is convergent evolution, meaning that these two species came together in a characteristic, but they're not related. They're not from a common ancestor. So that's like how another person I'm not related to has blue eyes. No, that's not a good example. Don't listen to that. Okay, so they're features that are similar in distantly related groups. They did not come from a common ancestor. So they arise or they come up, they evolve when two different groups of living things live in a common environment, and that characteristic makes the most sense to have. And we'll talk about that in a second. And then it says convergent evolution does not provide information about ancestry. So just because two things have a similar characteristic or a similar structure does not mean that they descended from a common ancestor. Does not mean that they're related. So a good example that your textbook gives is between these two kinds of rodents. One is found in North America called the flying squirrel, and one is found in Australia called the sugar glider. They are very similar. These pictures don't show them, it does show them as being similar, but they both have this kind of extra skin right here that helps them kind of glide. But the thing is that these two guys are not related to each other. They're both mammals, but this right here is the same kind of mammal that we are, which means that flying squirrels carry their babies inside of them when they're pregnant, whereas the sugar glider on Australia is a marsupial, which means that it gives birth to a very immature young and then carries it in a pouch like a kangaroo. So even though these two guys look the same, they're not related at all. They had a common ancestor that looked nothing like them, but they live in such similar habitats that this was what's most advantageous, and they both evolved to look very similar, which is very odd. That's an example of convergent evolution. So this evolved from the same common ancestor that we had. This evolved from the same common ancestor that kangaroos had, but they evolved to look the same. So that's convergent evolution. Let me give another example of convergent evolution and analogous structures are wings. So bats have wings, but bat wings are actually the same structure as our arm. Remember that? But that's different than butterfly wings, which are also used for flight, but those are evolved completely separately. So wings and flight evolved more than one time. So it's not like all living things that fly evolved the characteristic of flight and then diversified. It evolved several different times. So those are examples of convergent evolution or analogous structures. Another example of evidence for evolution is the fossil record. And so we can see that living things have changed over time because we can find fossils of living things that are no longer alive. Example number one, the dinosaurs. We know that dinosaurs are not alive. I'm pretty positive, unless they're hiding someplace very well. But we have fossil evidence for them. And we can see changes in the dinosaurs over time. We can see from fossil evidence that human beings have changed over time. So the fossil record provides evidence that living things have changed. And we can look back in time at the fossil record to get a picture of what life was like thousands, millions, billions of years ago. What is this picture of? This picture is not in your textbook, but it is a picture of teeth, I'm assuming. So here's a dog tooth, and then here's a pig. I don't know what these other things are. I'll come back to this. So we can see important transitions. We can actually see when living things moved like into the ocean or moved out of the ocean. For example, our ancestors, like the ancestors of all living things, used to live in the ocean. But whales live in the ocean, and their ancestors used to live on land. So we can see these kinds of things in the fossil record. The last piece of evidence is called biogeography, which is where we can see that living things that are similar kind of grouped together. So you've probably learned that at one time all of the Earth's continents were in one supercontinent. There was just one called Pangaea, but since then, because of the plates moving around and things like earthquakes and everything like that, we've spread out into 7 different continents. But we can see, if you look at where the continents used to all fit together, you can see similar living things across the continents. Is there a picture of that? No. But that's basically it. So where 2 continents used to touch, you can see a lot of similarities between living things that live on those 2 continents. And then endemic species are species that are found not anywhere else in the world. So these guys have kind of moved to one island and evolved there. So you know that they moved there on their own and then evolved those characteristics that are different because they're so different than any other living thing. But they probably would have a lot of similarities to whatever island is closest to them. And then Darwin, so the example, this is the Galapagos, of all the birds with the different sized beaks, etc., etc. And so Darwin used this to explain that species on islands give rise to new species as they adapted to new environments. And there are pieces of evidence for evolution.